I welcome you all for this lecture series on artificial intelligence and machine learning. In this lecture, we will briefly discuss about one example problem for uniform cost search. The uniform cost search, we are shortly calling it as UCS. UCS expands Uniform Cost Search. The uniform cost search is an optimal search algorithm that expands nodes with the least cumulative path cost first. It ensures that the first time it reaches a goal node, it does so with the least possible cost. And now we'll see the step-by-step procedure for this UCS, Uniform Cost Search. And here, by using this given graph, we'll see the step-by-step breakdown of how UCS works on the or for this graph. The first step is the initialize. The search starts at the root node. Here, this A, we are calling it as the root node. This node is the root node. UCS, Uniform Cost Search, uses a priority queue. Here, min heap queue it is using, where each element is a tuple of cost, node, and path. The search algorithm begins with the node A at a cost of 0. And we initialize the priority queue with 0. The 0 represents cost and A represents the node and the path is also A. This means the search will start at node A and path so far is just, what is the path? So far is just A. And the next step, we will expand the least cost node, and in this case, uniform cost search works by expanding the node with the least cost first. By considering this, we begin by expanding the root node A and expanding. So the next step is the expanding A. At this point, the cost is 0. The neighbor of A or B. What are all the neighbors? B and C with the cost B with the cost 2 and C with the cost 3. These nodes are added to the priority queue with their corresponding costs. The corresponding costs, and expanding B adds its neighbor D as 2 plus 5. So before that, the priority queue is 2 comma B and AB, and here the next node is 3 comma C comma A comma C. And next we are going to expand B from this. So this is the cost is low comparing to the 3 C node. So next point is we are going to expand B. Expanding B, what is the cost? The cost is 2. Expanding B adds its neighbor D with the cost 5. With the cost of 5 and E. Right? Here E is the cost is 1 to the Q. This we are going to put these values in the Q. The cumulative cost to reach D is what? 2 plus 5 is equal to 7. 2 plus 5, 7. And the cost to reach E is here 2, here 1. So 2 plus 1 is equal to 3. These nodes are added to the queue, and the priority queue now is 3 comma C and AC, and 3 comma E, AB, E, and 7 ED, AB, D. This is the priority queue, that is min heap node. Next step is expanding C. Expanding this C. Now C, the cost is 3, is the least cost node in the priority queue. And expanding C adds its neighbors E and F. E with the cost 8 and F with the cost 2 to the q. 2 to the q. The cost to reach E is 3 plus 8. 3 plus 8. 3 plus 8, 11. But E already exists in the queue with a lower cost of 3. 2 plus 1. 2 plus 1, it is already there in the queue. A lower cost of 3. So we discard this path. So this path, no, we are going to discard it because already E is in the queue. So discarding, I am using some other color. So this we are going to discard it. So that the cumulative cost to reach F is 3 plus 2. 3 plus 2, 5. So F is added to the queue. So now the priority queue has been written it as 3, E, A, B, E, 5, F. You just see the graph. ACS, ACF, 7D of ABD. We'll write it in terms of duple. Next step is expanding E. We are going to expand in the E. The next least cost node is E. Cost is 3. Cost is 3. And expanding E adds its neighbor G with the cost of 4 plus 6. 4 and 6. 4 and 6 to the Q. The cumulative cost to reach G is G through E is 3 plus 2, 1 and plus 4. So 2 plus 1 plus 4 is equal to 7, which is cheaper than the other path cost 3 plus that is 3. 2, 1, this 2, 1 and 6. So 3 plus 6, 2 plus 1 plus 6 is equal to 9. So we keep the path with the cost, this we are going to keep it, and discard the path. This path we are going to discard it. And the priority queue has been written it as 5, F, A, C, F, 7, D, and of A, B, D, and 7, G of A, B, E, G. This, just look into the graph. You can able to understand. Next, we are going to expand the goal node. Whether the goal we are reached or not. This we are going to expand it. The goal node G is now reached at a cost of 6. The goal node, how it has been reaching? G is reached at a cost of 6. Since uniform cost search guarantees that the first time it reaches the goal. First time it reaches the goal, it does so with the least cost. So we stop here and solution is found. And if you are looking into the return, so goal node is found, and the return, the solution, the path G is ACF. See here, 3 plus 2 plus 1. So what is the cost? 6. So we are reaching the shortest path. So the path we will be writing it as the least cost path is to G is A to C, and C to F, F to G. So comparing all those nodes, the path cost is very low. Here 3 plus 2 plus 1 is equal to 6. So G with the cost, we can write it as the cost is 6. So the final solution is A to C, C to F, F to G. So we are writing the cost is equal to 6. So coming into the summary, so first we expanded A, then we have gone into B and C, then E, then from F, and finally by comparing all these nodes, expand the node G. So both are goal node. whatever the node is getting with the minimum cost, we are finding it as the goal node. So expand the G, the goal node reached with the minimum cost. Here the cost is equal to what? Cost is 6. 3 plus 2 plus 1. So we have reached the goal node. So thus the algorithm expands nodes in increasing order of path cost, ensuring the least cost path to the goal, and it is always found first. The final result is optimal path. So what is the optimal path now for this problem? A to C, C to F, F to G, F to G, and we have to write the total cost for this problem is total cost of 6. This is the answer. So this problem could be explained in terms of table also. We'll see on a single table we can able to complete it. So this is the problem which I have taken already. This table clearly shows how UCS, that is uniform cost search, expands the least cost node first, ensuring the optimal solution. This table provides a step-by-step breakdown of how UCS, Uniform Cost Search, expands nodes in order of their cumulative path cost. This UCS ensures that the lowest cost path is always expanded first, making it an optimal solution algorithm for finding the least cost path. So in this case also, initialization. The first one is the initialization. The search starts at here. The search starts at node A with the cost of 0. Here we are writing it as the cost of 0. The priority queue initially contains B and C. B and B with the cost of B with the cost of 2 and C with the cost of 3. And expanding the node B here, the second step. If you are expanding this second step, since B, the cost is 2 as the lowest cost, it is expanded first and it adds D. It adds the D. What is the cost? 2 plus 5, 7. And it adds D cost is 7 and E cost. Here E, if you are going into E, and the cost is 3 to the Q. And expanding C, if you are expanding this, the cost is 3 is expanded. It adds to E here again. It adds E, cost of 11, 8 plus 3. What is the value? 8 plus 3 is 11. And F, cost is the 5. 3 plus 2, 5. However, since E, cost 3 is already here, 2 plus 1. Already we have added in the Q. With the lower cost, and newly found E, that is cost of 3 plus 8, 11 is discarded. And on the fourth step is expanding E, and it is the step 4, and the lowest cost node is E, and the cost is 3. Expanding E adds G, cost is 7, and the G cost 9. The cheaper path to G, cost 7, is kept while the costlier one is discarded. And expanding F, we have to expand this. If you are expanding this F, it is the step 5. Here we have to write it in terms of step 5. The cheaper in this, the next lowest cost node is F. Cost is 5. So 3 plus 2, 5 is expanded. Then adds G. Cost is 3 plus 2 plus 1. 6 to the Q. So this we are writing over here. And next expanding G. Step 6. Here step 6. The goal node G is reached at the cost of 6 via path A, C, F and G. A, C, F and G. So once if it reaches the minimal cost A, C, F and G, since UCS guarantees the least cost path, we stop the search here. So the final answer is what? A to C to F to G. So the total cost is 6. So this table effectively illustrates how UCS, that is Uniform Cost Search, expands nodes based on cost priority, ensuring that the first time a goal node is reached, it is through the least cost path. And finally, we are writing in the table goal node priority queue. We are writing it as the goal node is reached. So what are all the key takeaways on this uniform cost search? Uniform cost search is a simple yet effective algorithm for finding the shortest path to a goal node, and it expands nodes based on their cost, and it uses a priority queue to effectively manage nodes, and it is guaranteed to find the optimal solution at the same time if the cost is admissible. And the applications of the uniform searcher, it is used in the pathfinding in video games, route planning in logistics and transportation, and network optimization. Hope everyone understood this simple algorithm. Thank you for your attention. Thank you once again.